this video will graph this function h. So first we'll factor the top polynomial and the bottom polynomial. So to factor the top, it's the sum of two cubes. So we'll use the sum of two cubes formula, and that should be what you get. To factor the bottom, we'll factor out the GCF, which is x times x plus 2. Okay, so first of all, the domain of this function. To look at the domain, we'll have to look at the denominator. So we'll exclude the numbers that will make the denominator equal to 0. That's 0 and negative 2. Right? So if you graph a number line, negative 2 is here, 0 is here. If you want to exclude those 2 points, your domain would be from negative infinity to negative 2, union from negative 2 to 0, and union from 0 to infinity. That's the domain. Now, after that, let's see if this function is in lowest terms. So it looks like it is in lowest terms because we cannot cancel out any common factors. That means there are no holes in this graph. Now next, let's find the x-intercept and the multiplicity for each x-intercept. So we have to look at the numerator. It's pretty obvious we have negative 1 as our x-intercept, and the multiplicity for that is 1, which is odd. And from this part, if you want to find the 0 of that part, you can probably see this has no solution. You can try to solve it using the quadratic formula, which is 1 plus or minus square root of negative 1 squared minus 4 AC divided by 2 times A. You can tell this part is negative since you have a negative number underneath the square root. That equation has no real solutions, so you don't generate any x-intercept from this part. All right, now y-intercept. To look at y-intercept, we need to make x equal to 0. So you want to make x equal to find h of 0. Excuse me. So on top you have 0 cubed plus 1. At the bottom you have 0 squared plus 2 times 0, which is 0 at the bottom, 1 on top. This is undefined. So that means you don't have any y-intercept. Now vertical asymptote. And the multiplicity for each vertical asymptote. Okay, so to look at the vertical asymptote, we look at the denominator. We are trying to find the zeros of the denominator, which we already did. One is 0, one is negative 2. So we have two vertical asymptotes. One is x equals 0. The other one is x equals negative 2. And the multiplicity for each is 1. So they're both odd. Now, horizontal asymptote or oblique asymptote. We'll look at the degrees of the top and the bottom, right? So the degree of the top polynomial is 3. The degree of the bottom is 2. Since the degree of the top is 1 more than degree of the bottom, we don't have any horizontal asymptote. We have an oblique asymptote, and we have to find it using long division. So here we go. We put the numerator inside, so that's x cubed. We don't have any x squared terms, so we have to write 0x squared. We don't have any x terms, so 0x, and then plus 1. And next is x squared plus 2x. Don't have any constant terms, so write plus 0. Okay, now, since you have 1, 2, 3 terms in the divisor, the first term will appear on top of this 0x because that's 1, 2, the third term. So we need a term on top of 0x such that this term times x squared will give me x cubed, which is x. X times x squared is x cubed, keep multiplying. X times 2x, that's 2x squared. And then keep going. X times 0 is 0. Now subtract. X cubed minus x cubed is 0. And 0 minus 2x squared is negative 2x squared. Last term, 0 minus 0 is 0. 0x. Drop the last term. That's a positive 1. Okay, now the second term of the quotient. We need a number here or a term here so that this term times x squared will give me negative 2x squared, which is negative 2. And keep going. Negative 2 times 2x is negative 4x. Negative 2 times 0 is 0. Draw a line and subtract. So since these two are the same, that's a 0 subtracting. Right? 0x minus negative 4x is a positive 4x. 1 minus 0 is 1. So this is the remainder, and x minus 2 is the quotient. That gives us the oblique asymptote, which is y equals x minus 2, which is the quotient. All right, now we want to find out if our graph will intersect the oblique asymptote, which is y equals negative 2. We'll use the same method. We will put the two equations in the system. So the equation for h is like this. And the other equation is y equals x minus 2 is the oblique asymptote. We want to solve the system by substitution. Now cross multiply. We have x minus 2 times x squared plus 2x equals x cubed plus 1. Distribute. So x cubed plus 2x squared minus 2x squared minus 4x equals x cubed plus 1. Right, so combine like terms over here, that's a 0. Cancel out the x cubed term, you have negative 4x on the left side, 1 on the right side. So solve the equation, you have x equals negative 1/4. That means when x equals negative 1/4, your graph will intersect the oblique asymptote, y equals negative 2. Right, so the two graphs will intersect at x equals negative 1/4. All right, I think we gathered enough information. Now let's graph. So this is my coordinate plane, x and y. Now first, let me write down the x-intercept, which is at negative 1. Use this color. So it's odd. Okay, now we don't have any y-intercept. We have two vertical asymptotes. One is at x equals 0. X equals 0. We have a vertical asymptote there. The multiplicity is odd. The other one is x equals negative 2. It's over here. X equals negative 2. The multiplicity is also odd there. Now we have an oblique asymptote, which is y equals x minus 2. So it's over here, up 1 over 1. So this is the line of y equals x minus 2. That's the oblique asymptote. So y equals x minus 2. And our graph will intersect the y equals x minus 2 at negative 1/4. So it's around here. Our graph will intersect the oblique asymptote. All right, let's start graphing. That's all the information we gathered. We can start graphing. All right, first of all, we will have to connect the x-intercept with this point where the graph intersect the oblique asymptote. Right, connect those 2 points. Okay, since the multiplicity for this x-intercept is odd, our graph will pass it and go up all the way. Right. Since the multiplicity for this vertical asymptote x equals negative 2 is odd, that means if one side is going up, the other side will go down. So on this other side is going down. All right. Since we only have one point in our graph passing the oblique asymptote, which is over here, so we won't pass the oblique asymptote anywhere else. So our graph will behave like this. All right, now let's go back to this point. So it seems like our graph will keep passing this oblique asymptote and go down like this. And since we have a vertical asymptote over here, and one side is going down, the other side needs to go up because the multiplicity is odd. So the other side needs to go up. And since our graph won't pass the oblique asymptote anymore, we'll just go like this, getting closer and closer to it, but it will be above it all the time. And this is our graph. And I hope you find this helpful, and I'll see you in the next video.